All right. Hello, everyone, and welcome to today's webinar, How to Justify the Cost of New Equipment. This webinar is brought to you by Applied Software. My name is Misty Scott, and I am pleased to be your moderator today. We'll begin with a quick intro video on how to get the most out of this webinar and interact with us today. Okay, here we go.
Hi, and welcome to this Applied Software webinar. We're glad you could join us today. Get more out of the webinar by clicking on the icons at the bottom of your screen. You can resize these. This button leads to resources. This button adjusts the volume. Just don't push this one. I'm watching you. Be sure to find Applied Software on social media and on our website, ASTI.com, where we'll empower you to discover what's possible. You can also find a complete schedule of upcoming events, on-demand webinars, and training on our calendar at asti.com/calendar. This is being recorded for your convenience. You'll be receiving an email with the recording link for future reference. And make sure to stick around. We'll answer questions at the end. See you there.
Awesome. And as the video mentioned, you can find a schedule of upcoming events, webinars, and training on our calendar at asti.com/calendar. So make sure you check that out. Okay, so I am super pleased to introduce our speakers for today's webinar. We have a fantastic panel of industry experts for you guys today. Joining us is Jason Flores, who is a strategic industry consultant with Applied Software. He has over 15 years of experience in the Autodesk channel with a focus on software and service management. Secondly, we have Todd Schmuck, who is a senior application specialist with 18 years of Autodesk channel experience and a focus on Autodesk manufacturing, digital factory, and AutoCAD electrical. Finally, we have Mike Siebert, who is a senior consultant with an impressive 35 years of production and fabrication experience. And Todd focuses on helping clients achieve their goals with an expertise in digital factory, Revit, CAD, MEP, and Navisworks. Thank you guys for joining us today. I know you've got a lot of great content in store for us. And for those attending, if you have any questions throughout the webinar, go ahead and plug them in the chat box. We will have time to answer those after our session here. Okay, without further ado, I'm going to turn it over to you guys.
Todd, can you hear me okay?
I can hear you.
Can you see my slides?
I can.
All right, great. Let's get started. So hello, everybody. Welcome to our first webinar in the ProModel series. Today we'll be discussing how Autodesk and ProModel can help you decide if adding a new piece of machinery to your factory floor can help or actually hurt your company's productivity. I'm your host, Jason Flores, and I'm an industry consultant here at Applied Software. One of my focuses is helping customers understand what a digital factory means to them and how they can leverage technology not only to gather data about the factory, but more importantly, what we can do with that data after the fact to help operation folks make decisions that will affect throughput and efficiencies. So co-hosting this event with me is Todd Schmuck, Senior Application Specialist, and Mark Siebert, Senior Consultant. As I mentioned, today marks the start of the webinar series, which has ProModel at the center. Prior to my introduction to ProModel, my customers had a great understanding of how their equipment and people fit inside their factory using AutoCAD and potentially even factory design utilities. But their understanding of the flows and changes that would impact that factory floor was left entirely up to historical data, or worst, a hypothesis of how that change will affect the company. So when I saw ProModel and what it could do with the different scenarios that can be thrown at it, a light bulb kind of went off in my head, and I've been promoting its use ever since. One of the challenges I've helped customers overcome is the complexity of the digital factory concept itself. With so many moving parts and solutions that are involved, it can be quite overwhelming, to say the least. Things like AutoCAD, factory design utilities, ProModel, raster design, point clouds, Navisworks, 3D scanning, all of these sorts of things can really make your head spin. So through this series of webinars, we're going to take bite-sized pieces of information and workflows and try to help demystify the world of digital factory as we know it today. So, if you ever ask yourself some questions, have you ever thought about adding a new piece of machinery to your floor? Ever wondered what sort of impact this will have? Have you ever assumed adding more equipment will increase throughput? But then you ask yourself, what about upstream and downstream implications too if I add that new machine? And how can you predict all this? Has your company physically laid out this concept or this new machine only to find out it really did not have the impact you expected? So today's webinar addresses this challenge and takes you on a journey of two people trying to understand the impacts of adding new equipment, and they're going to use ProModel to help them make decisions faster and with a better understanding than they've ever had before. So with that, I will turn it over to Todd Schmuck and Mark Siebert, who will kick off today's demonstration of ProModel. As we're going along, feel free to chat any questions you have along the way, and at the end, we can try to answer any of those questions.
The layout you see is a manufacturing cell of a larger factory layout. It was laid out using the factory design utilities. Factory design utilities is a set of tools that help you accurately represent your existing factory or proposed factory layout. With factory design utilities, a ribbon is added, giving you tools that help you lay out the factory floor. One of the tools is an asset builder. You can take your existing CAD files that represent your one-to-one footprints, and you can publish them and add them to your user assets. But there are also assets that come out of the box. And these are the categories. There are several categories that you can pull from. If you do publish your own, you can either publish them to this location or another one that you can identify. But once you get them published, you just simply drag and drop and position that asset in the location that it's needed. With these assets, there are parameters that can be identified. So in this case, looking at the CNC machine, we're looking at whether the door is open or closed, so there's a true and false. And there's other parameters that have been identified for the height, length, and width. So in this scenario, we're looking at, with the existing CNC machine, we need to have more output. So will a second machine solve the answer, or do you need additional personnel? So first you want to run a scenario of how the existing layout is, in this case with one machine. And this is where ProModel comes in handy. So ProModel adds a ribbon to the user interface with a set of tools. And you identify those assets as locations. So if you look over here in the simulation browser, all of those assets have been identified as a location. And this green arrow and lines, set of lines, represent the flow of the material or the part. You also identify the flows and where is that material or part flowing through the different stations. So in this case, we're looking at the CNC lathe, and with that, you can add, once the flows are identified, you can add additional data and criteria. So in this case, looking at the CNC lathe existing with just one, there's 100% of the parts are going through that machine. In another scenario that we will run, we'll add another CNC machine, and then we would have to split that percentage up. So once the route is created and the flows are determined and the values have been added, you can use a tool called Simulate on the ProModel ribbon. And then this will actually simulate the route of that part or material going through the various stations. And in this case, finished and reject criteria have been set up. I'm going to fast forward this to the end because I want to be able to lay out the various charts to get information that I can evaluate. So in this case, an output viewer will open, and charts can be created to suit the need that you have for identifying the proper information that you are trying to establish. And those charts are created using this tool right here. So another simulation will be created adding a second lathe. We'll look at the results, and then we'll evaluate the results. The proposed layout of the two CNC machines has been completed. You can see the second machine is now added, and the paths have been adjusted. In the ProModel simulation browser, the second lathe has been added. The values have been adjusted. So, for example, in CNC lathe 1, the percentage is now down to 50, and on lathe 2, the percentage of parts going through it is now at 50. Now that that is all done and any other adjustments were made by adding the second machine, on the ProModel ribbon, I can go simulate it using the Simulate tool. ProModel shows the parts running through the route. The finish and the reject are being adjusted and displayed as the simulation progresses. I'll fast forward the simulation just like I did the last time so I can get to the simulation results. The output viewer displays. And just like in this scenario where we had one machine, the same charts have been displayed, so now I can compare the results of the two simulations and evaluate whether adding the second CNC machine gives us the desired part output.
Now that we've run the simulations, we can open up our output viewer and look at both simulations in the same screen. By just coming here to File and going to our data source, we can add our data source for the single CNC machine as well as having two CNC machines run. Now, looking at our report data, as we can see by looking at the two different results, we can start seeing how the second CNC machine, though thinking that our operation percentage would increase, actually has decreased, and that we have actually increased our percentage of block time from a 26% rate to a 30.5% rate. So let's look at the single capacity of the location. So right away, we can see that both of our box containers in Simulation 1 and Simulation 2 are both very high. And we saw that while we were watching the simulation stack up on the conveyor belt. But as we look, we can actually see that we have only decreased the percentage of block from 65% down to 64%. So it was only a 1% difference in adding a second CNC machine. The thing that I found most interesting, though, was that with the single CNC machine, we only had a 1% blockage on that one CNC machine for the throughput. While when we added on the second CNC machine, you can actually see that we increased the blockage on the first CNC machine up to 28%. Notice that our inspections are considered to be full on both situations. So actually our inspection and our finished parts actually did a better job, but as we can see with our scorecard, we have fewer objects coming off the line. Our average time in the actual system is increased by almost 20 minutes. And our average time just in the operation part of itself has increased by 8 minutes. So the cost of our COG is now more expensive and our throughput is fewer. So adding the second CNC machine was not the best solution. So looking at our output data, maybe one of the things we have to start considering is where our bottlenecks really are showing up. So in our original report, we were looking at our entity states. Let's take a closer look at those entity states. If we take a look, we notice that our in-move logic, our waiting logic, as well as our operation are really close to each other. 55.6% is here in operations. When we go to a second machine, we actually lose 4%. That 4% turns into our percentage of blockage. But what's really causing that blockage? Well, let's take a look at some states that our machines were used to see what kind of usage they've got. If you notice our degrease portion of the process, it is only full 85% of the time. Only 12.21% are the parts occupying it, and the machine is empty 2.79%. We come over here to our check system, and our check system is never full. We have 97.27 parts occupied at all times. So in other words, this is probably holding us up for the inspection. So maybe what we need to do is add on a second person to the inspection site to alleviate some of the blockage. Now, one other thing that I want to look at in our variable summary, I want you to realize that when we only had one CNC machine, we produced 47.6 units, and we only had 6 rejected. When we added on the second machine, it actually decreased our production rate, but it also decreased our rejection rate. So in this case, we can start seeing how the resources of having just one operator doing the whole process might be overtaxing. But the other thing we need to start looking at is in our inspection or our degrease process, we might want to look at a different process here, or maybe adding on a station to help alleviate some of the blockage that the CNC machines are doing. This might be what we need to do to increase our productivity, yet keep our costs down.
So far, everything has been completed in AutoCAD. If you feel more comfortable working with Inventor, the factory layout can be completed in Inventor and opened in AutoCAD at any time. In this case, I started with AutoCAD, and I would like to open it up in Inventor. So there's a tool up here on the factory ribbon, Open in Inventor. Inventor will start, and it will create the factory layout as it was created in the AutoCAD software. So you can see the factory floor now is displayed here in Inventor. The same CNC machine that I picked on last time, if I click that, you will see that the factory properties displayed, the same factory properties that were shown in AutoCAD, the door open, true or false. There's a parameter for height, length, and width. The same asset browser with the assets that were available in AutoCAD are available here. System assets, the ones that were out of the box, and all of the options that you had there. User assets, the ones that you would publish to. And in this case, I have favorites created, and I have it populated with items that I use on a regular basis. So in this case, maybe I want to take a fork truck from my assets and drag and drop it in to my factory floor. I position it in the location and orientation that I want, and I can continue to add assets, dragging and dropping them where I need them. When I'm ready, I can go back to AutoCAD at any time. So I'll use the tool Open in AutoCAD. The layout will need to be saved. And now we are back in AutoCAD, and you can see the fork truck has been added. At any point, I could move any one of these assets to a different location or remove them, save it, open it up in Inventor, and Inventor will be updated. So in any order that you prefer to work in, you can work in. And at the very least, you may just want to work in AutoCAD, and the only reason you go to Inventor is to create a presentation for upper management.
All right. Thank you, guys. I think we had a little disconnect there, but that is okay because we had fantastic content. So as promised, I did want to open up the chat box here. We do have a couple of questions in there. So the first one here, it says, as mentioned, this was a series. When is the next one scheduled for? And if you want to answer that, Jason, I see you have come on here.
Sure.
To see if you can, yeah. What do we have the second one scheduled for?
The next one is scheduled. We're trying to do these quarterly. So the next one's scheduled for June 23rd. And
Fantastic.
It is entitled, the best way to increase throughput in your factory floor. We'll talk about changing some workflows, adding some people, adding a machine, and sort of see the different scenarios there.
Okay, very cool. I'm excited about that one. I think it'd be really, really awesome. And
It'll
then
we're trying to make these to build on top of each. We're trying to make these to build on top of each other.
You know what? I really love that, and I love that it's you've got snippets of information, so it's very easy to digest. And then coming back to the next one, you'll be able to really pick up where you left off. So I think that's great. All right, we've got another question. If we are interested in any additional training resources, who do we reach out to?
Yeah, you can start with me, and we'll set something up for you. I don't know how to get them my contact information, the attendees, but I'll sort of spell it out. It's jflores@asti.com. And I know that you probably have some of my contact information with the communications around this webinar. So.
Yep, we absolutely do. And you guys, his contact information is in the speaker bio over to the right. So you can find that information there as well. Okay, awesome. Well, I want to thank you all for joining us today. We super appreciate spending time with you and trust it was meaningful and impactful for yourself and your businesses. And we look forward to seeing you at future webinars. So thank you all and have a wonderful day.
Thanks, everybody.